All right, 1.5, measuring and constructing angles. It says find the measure of the following angles. Classify each angle as acute, obtuse, or right. So AOB. So for AOB, we're going A to O to B. All right. Now, obviously, this is a smaller angle. Now, if you notice, we have numbers going this way, 0, 30, 40, 50, 60. On the outside, we have bigger numbers going this way, 0, 10, 20, 30, 40, 50, 60, and so forth. We want to use the smaller numbers, all right? So this one is between 0 and 30, and then if you count, it's 31, 32, 33, 34, 35. So that's going to be 35 degrees. All right. COD. Well, for COD, we have C, then O to D. Now, this is a little bit different because it's not starting at 0. So if you got to look, this one is 70, and this one is 115. All right? If you're looking on the outside numbers. So 70 and 115. If you do 115 minus 70, you get 45 degrees. Or if you look at the inside numbers, this one was 110, and this one was 65. Same thing. If you do 110 minus 65, you're going to get 45 degrees. So you can do it either way you want. And then BOD, this is getting a little messy here, so I'm going to clean this up. BOD, all right, goes here, here, and here. So again, this is 70. It's the same segment we used before, same ray we used before. And over here, if we're using the outside numbers, 145. If we're using the inside numbers, here is 110, and here is 35. Either way, if you subtract those, you're going to get 75 degrees. And that leads us to the postulate that basically says the measure is the absolute value when you subtract the numbers. So again here, if you use the outside numbers, you have 40 and 180. Subtracting, you get 140. Or the inside numbers, which is the easiest, 0 and 140. You're not usually going to probably do that subtraction when it's starting at 0 because you just got to look at the number, all right? But what's confusing is a lot of times people will look at this angle and they'll look at this and go, oh, it's 40. No, it's too big to be 40. You got to use some common sense there. All right, a lighthouse keeper measures the angles formed by the lighthouses at point M and 3 boats. Name 3 angles shown. Well, you got to use 3 letters. So we have JMK. So angle JMK. We have angle KML. And we have JML. Now, just a reminder, I could have called this KMJ, going the opposite direction, LMK, again the opposite direction, or LMJ, going the opposite direction. Notice, though, M is in the middle all the time. This point must be the middle letter. You cannot call it JKM. Just be careful about that. Now, there's 4 types of angles. We have acute, which is a cute little angle, less than 90. We have a right angle. It's 90 degrees, like most corners, all right? Obtuse means bigger, greater than 90, but less than 180. And then you have 180, which is called a straight angle. All right? So find the measure of each angle, again, like we already did earlier. GHK. Well, that's pretty easy because we're starting out at 0. So I'm just going to look and see, okay, I have a choice here. It's either 55 or 125. Well, if I look at this angle, that is open past 90. So that's 125 degrees. All right, JHL. J to H to L. Well, that's pretty easy because that's either 90 or 90, so it's just 90. It's right angle. And then LHK. L is here. H, K. Now here's where I have to do that subtraction thing again. Now here, either way, it's 90. Okay? And then here, I have a choice of two numbers. Either it's 55 or it's 125. Sorry, I don't know why my pen is not writing completely. Either way, when I subtract those, okay, 90 minus 65 or 125 minus 90, I'm going to get 35 degrees. And when I say absolute value in the postulate earlier, I could actually do 90 minus 125, which is negative 35, but then the absolute value, which is always positive, would be 35. All right, example 3. Identify the congruent angles. So what we're looking for is symbols that are showing congruency. So those two matching arc marks are congruent. Now, I actually have two choices here. Since no other points are labeled, I could actually just say angle F and angle D. All right? But if I had letters here and all over the place, I would have to name them like this. Angle maybe GFE, or I could call it EFG, and angle ADC, or CDA. But since those are the only letters around and the only possible for F and D, I can just call it that. Now notice, there is an arc mark down here, but it only has one arc. So I'm going to look real closely and see, is there any other one arc marked on here? I don't see one, so those are my only two matching congruent ones. Now, it says if angle ADC is 140 degrees, what is EFG? Well, remember, EFG is the same as GFE, just a different order. They're congruent, so it's also 140 degrees. So the angle postulate rule, it says if P is in the interior, which means inside that RST, then if I take RSP and PST and add them together, I get the overall RST. Okay? That's just like building. If I take this angle and I put them together, I get that angle. All right? Pretty basic. So, I know this angle here is 2x plus 10. I also know this angle here is 4x minus 3. And I use different number of arc marks because they're obviously not equal. Right? And you can also not assume that 4x minus 3 is equal to 90. It looks like it is, and maybe it will end up being 90. But for right now, it could be 91, 89, it could be 89.5, it could be 89.9. We can't assume unless we see this mark saying it is 90, and we don't, so we never assume. But what we do know is that this angle here plus this angle here adds up to a total angle of 145 degrees. So we just write that. This angle here plus this angle here adds up, right? Adds up to 145. Now I'm just going to do some basic algebra. I'm going to combine my like terms and get 6x. I'm going to say 10 minus 3 is positive 7 and get 145 still. Now I'm trying to get x by itself, so I'm going to subtract 7 from both sides. That's going to give me 6x equals 138. 45 minus 7 is 38. All right? And then I'm going to divide by 6 on both sides to get it alone. And that's going to give me x is 23. Now, is that what I was supposed to do? No. It says find the measure of LKM and MKN. So I need to plug 23 in right here and right here. All right? So LKM, angle LKM is 2x plus 10. So 2 times x, which we found out to be 23, plus 10. So that's 2 times 23 is 46 plus 10. So LKM is 56 degrees. Now I have two choices here. I can say that MKN is 4x minus 3, and say 4 times 23 minus 3. Now 4 times 23 is 92 minus 3, and that's 89. Oh, look, remember how I said you couldn't assume? It turns out it was really close, but not 90 degrees. Now, I actually could have done this a little bit faster. Since I knew that this angle was 56, and I knew they added up to 145, I simply could have done 145 minus 56, and that would have given me 89 degrees. So more than one way to do it. Now, here we need to do a drawing. We weren't given one. So QS bisects. So here's Q. Here's S. Bisects PQR. That means that this angle here is going to be equal to this angle here. So I'm going to try to draw it about the same size. So here's PQR. Bisects means it cuts it in half. Now it says PQS is 24 degrees. Find PQR. Well, if this is 24 degrees, then this is 24 degrees. So therefore, PQR is 24 plus 24, or 24 times 2. Either way, 48 degrees. Always pay attention to what it's asking for. It might have asked you to find SQR, which would have been 24 degrees. So always pay close attention to what it's asking. And then again, an exit ticket. So this you're going to do on your own. Angle MNP is a straight angle. That's a line, 180 degrees. And NQ bisects MNP. It cuts it in half. Think about that. Draw angle MNP and NQ. Use arc marks, like I showed you, to mark congruent angles and find the measures of the angles. So you're going to draw that right here, and we'll discuss it in class.